Why is that even a difficult problem? Well, because if we try solving it the usual way, then we have to expand the left-hand side, which means that we have to multiply these two quadratic trinomials, which is a difficult task itself because it looks like that. And after we have done that, we are left with an equation which looks like that, and now we have to try and guess the roots of that equation. And to do that, we have to think of divisors of 30. And 30 has a lot of divisors, plus minus 30 itself, plus or minus 15, plus or minus 10, plus or minus 6, plus or minus 5, plus or minus 3, 2, and plus or minus 1. So we have 16 divisors here, and we have to plug them into the equation one by one and see whether the number is a root or not. For example, in a case of 1, we would get 1 to a power of 4 plus 14 times 1 to a power of 3 plus 65 times 1 squared plus 120 times 1 plus 30, and it obviously is not 0. So x equals 1 isn't a solution. And we have to check every number here, which means that eventually we will have to raise 15 to a power of 4, multiply 14 by minus 6 to a power of 3, so it's not a lot of pleasure. Actually, judging by the positive coefficients of the polynomial at the left-hand side, we can say that none of the positive divisors of 30 is a root of that equation. But still, it leaves us with 15 possible roots, and we have to check each of them. And in the end, none of them is a root of that equation, which is not surprising because the roots of that equation look like that. So we would never have guessed that. So how do we actually solve that equation? The idea is following. Let's find the arithmetic mean of these two quadratic trinomials. So we would have x squared plus 9 plus 5 is 14, and divided by 2 it's 7x, and 17 plus 3 is 20, divided by 2 it's 10. And let's introduce that as a new variable. So let's say let x squared plus 7x plus 10 equal 10. And x squared plus 7x plus 10 is once again the arithmetic mean of these two quadratic trinomials. Now we can see that that trinomial is t plus 2x plus 7, because we need to add 2x to 7x to get 9x, and we need to add 7 to 10 to have 17. And that trinomial is t minus 2x minus 7. It all equals to 21. So the left-hand side is t squared minus 2x plus 7 squared, which is equal to 21. And if we now expand these parentheses, then we will actually have t again. Let me show you. T squared minus 4x squared plus 28x plus 49 equals 21. So this is 4 times x squared plus 7x, which is t minus 10. So it's 4 times t minus 10. So we have a quadratic equation here, or t minus 40 plus 49 equals 21. T squared minus 4t minus 9 equals 21. And we finally have got t squared minus 4t minus 30 equals 0. And that is a basic quadratic equation. Let's solve it using a quadratic formula. The discriminant equals 16 plus 4 times 30, 120, which is 136, or 4 times 34, which is 2 squared roots of 34 squared. So t is 4 plus or minus 2 squared roots of 34 over 2, or t is equal to 2 plus or minus square root of 34. And since t equals x squared plus 7x plus 10, we have got two equations. X squared plus 7x plus 10 equals 2 plus square root of 34, or x squared plus 7x plus 10 equals 2 minus square root of 34. So we have to solve these two quadratic equations, and solving them isn't that much of a problem. Let me just tell you that this one doesn't have any solutions. And the solutions of this one are 1/2 times 7 plus or minus square root of 17 plus 4 squared roots of 34. And that is the answer to our problem. So thank you for watching this video. I hope you learned something new.